Electricity keeps our world running, but inefficiencies in transmission lines cost ratepayers millions. Advanced conductors like ACSS-TW can change that. Let's dive into the data from a landmark study to see how. Line losses are a big deal. The Aluminum Association's 1998 publication 54 explains losses grow with the square of the current. At 595 amps, or 35% of capacity, the 795 kilo circular mills ACSR Drake loses 50.8 kilowatts per mile. That's energy you pay for, but never use. At just 170 amps, or 10% of capacity, it's still 3.69 kilowatts per mile. Over 50 years, these losses add up. Advanced conductors can help. Meet ACSS-TW steel core conductor powerhouses. The study analyzed 50 years of costs. At 10% of capacity or 170 amps, steel core ACSR Drake is cheapest at $4,156 per mile per year in fixed costs. Bump the load to 15% of capacity or 255 amps, and the 959 kilo circular mills steel core ACSS-TW Suwannee conductor wins at $11,625 total annual cost versus Drake's $11,946, thanks to losses dropping to 6.74 kilowatts per mile. At 25% of capacity or 425 amps, the Suwannee conductor saves more, with $23,085 versus Drake's $26,216. At 35% of capacity, or 595 amps, the 1,031 kilo circular mill steel core Mississippi conductor shines, losing only 37.6 kilowatts per mile and costing $41,943 annually, $9,613 less than Drake conductor. Plus, Suwannee conductor boosts capacity by 99%, and the Mississippi conductor by 105%, more than doubled Drake's capacity. Plastic composite cores like 1,025 kilo circular mills, ACCC Drake, sound promising, but look closer. They cost $44,723 per mile upfront, twice ACSR's $21,874, because installation's tricky. Plastic's fragile cracking risks mean special tools and training are needed, increasing labor costs. At 595 amps or 35% of capacity, ACCC loses 38.4 kilowatts per mile, barely better than Suwannee, and 0.8 kilowatts worse than Mississippi. Yet its annual cost hits $44,307 per mile per year, exceeding the cost of all ACSS-TW conductors. Plastic only wins when SAG fixes a bigger problem. But for efficiency, steel core ACSS-TW is the best option. The study's sensitivity analysis seals it. Below 13% of capacity, or 221 amps, ACSR Drake shows favorable results with low first costs. Above that, losses take over. At 255 amps, or 15% of capacity, Suwannee's $6,290 energy loss cost beats Drake's $7,790. By 425 amps, or 25% of capacity, Drake's $22,060. Loss cost dwarfs Suwannee's $17,750. At 595 amps, or 35% of capacity, Mississippi's $35,090 loss cost saves big over Drake's $47,400. Data from MISO's 2024 Cost Guide and IEEE 738 2012 confirms higher loads favor ACSS-TW's low resistance and steel strength. Steel core ACSS-TW cuts losses, boosts capacity, and installs without fuss, backed by ASTM B857 and decades of steel reliability. Ratepayers save millions over plastic cores or traditional ACSR. This is the future of power, reinforced with steel, proven by data, powered by Bekaert.